Now the next we are going to start, that is trigonometric equations. So first of all we have to understand trigonometric equation. That means equation which contain trigonometric functions. So equation which contains trigonometric function as variable is called trigonometric equation, and a trigonometric equation that holds for all values of the variable in its domain is called identity. That is, for example, cos square theta plus sin square theta is equal to 1 hold for all theta belongs to R. So this is called identity and equation. If we have equation, our next question arises that what is its solution? So we have to find the general solution. So what is meant by general solution? A general solution to an equation is the set of all possible solutions so that solution of that equation. That is, we get all possible solutions. That solution are called general solution. They may be infinite solutions. So due to periodic nature of trigonometric function, if a trigonometric equation has a solution, that is, it may have infinite many solutions. Suppose the equation has pi by 6 as a solution and it is in the form of sine, then we can say pi by 6 plus 2 pi, that is 13 pi by 6 is also its solution. Then adding plus 2 pi again, we get so many infinite solutions due to the periodic nature of these trigonometric functions. So set of all solutions, that is called general solution. Now to understand this, we consider the graph of sine function, that if we draw the graph of y is equal to sine alpha, then any of the horizontal lines y is equal to k, where k varies from -1 to 1. That is, we are going to draw the diagram, that is a graph of sine. This is x-axis and this is y-axis. So if we take here 1 and here -1 and here pi by 2, pi, 3 pi by 2, 2 pi, and here minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, then we will draw a straight line. So on drawing the graph, sine 0 is 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is -1, sine 2 pi is 0, and so on. And also in the same case here, sine pi by 2 is -1, sine pi is 0, sine -3 pi by 2 is 1, and so on, and we are going like this. So we can see that from above graph, we see that y is equal to k. Intersect the line, that is, if we say y is equal to k. Intersect the line at so many points. So from above graph, we see that graph of y is equal to k intersects y is equal to sine alpha in infinitely many points. This means if a belongs to -1 to 1, then there are infinitely many real numbers x such that sin x is equal to a. But if we restrict the domain minus pi by 2 to pi by 2 and pi by 2 to 3 pi by 2, etc., then we get a unique number alpha such that sin alpha is equal to a, and horizontal line y is equal to a, where mod a greater than 1 will not intersect y is equal to sin alpha at any point. So by restricting its domain, we can get only one solution. So in the case of cos, we will see what happens. Now consider the graph of y is equal to cos x, and for y is equal to k, cos x intersect x-axis at infinitely many points. That is, it has infinite many solutions. That will be understood by considering the graph of cos function. So we are going to draw the graph of cos function. This is x-axis and this is y-axis. And we have 1 and 1 minus 1. So this is a line y is equal to 1 as k is vary from minus 1 to 1. Just make the graph by using scale. I am just making it roughly freehand. So you can use a scale. Just see. Here at 0, cos 0 is 1, at pi by 2 it is 0. And cos pi is minus 1. And cos minus pi is also minus 1 because cos of minus theta is theta. So you can see here at y is equal to k, cos k and minus k are here, and we take this as y is equal to k and y is equal to minus k. You can see it cut the curve at so many points. So it has so many solutions, that is this point, this point, this point, this point. These are the solution of y is equal to cos x. So to restrict this graph or to restrict its solution, if we take 0 to pi, then we get it intersects at one point, this one point, this is the solution, this is the solution. We take this point at y is equal to k, this is the solution. So we get only one solution. So to restrict zero to pi closed interval, we get only one solution for cos x is equal to a. Now we will consider the case of tan function. Now consider for the function y is equal to tan x. We draw any horizontal line in the plane it will intersect the graph of y is equal to tan x at infinitely many points. This means that if we take A belongs to R, then there are infinitely many real numbers x such that tan x is equal to A. So, by considering the graph of tan function, just as we done in the case of sine and cos graph, this is the x-axis and this is y-axis. And we have this is minus pi by 2 and this is pi by 2. So we get the graph of tan just like that. It is not defined at infinity. So at 3 pi by 2, it has a graph just like this. And at minus 3 pi by 2, it has a graph just like this. So we can say if we take y is equal to 2, y is equal to minus 3 and so on. So we can see it cut the axis at this, that is infinite solution. That means if we restrict the domain minus pi by 2 to pi by 2, you can see here it will get only one point. If we take y is equal to 2, we see in this domain it cut the point at 1. So it has only finite solution, that is one solution. So we get only one value or one solution for y is equal to tan x is equal to A. Thus, for any A belongs to minus 1 to 1, there is a unique alpha belongs to minus pi by 2 to pi by 2 such that A is equal to sine alpha. And for any A belongs to minus 1 to 1, there exists a unique alpha belong to 0 to pi such that A is equal to cos alpha. And for any A belong to R, there exists a unique alpha belongs to minus pi by 2 to pi by 2 such that A is equal to tan alpha. So we get the unique solution for cos alpha is equal to A, sin alpha is equal to A and tan alpha is equal to A in the restricted domain. Now we know that set of zeros of sine, cosine and tangent function also. Zeros are those points that satisfy the equation. That is, to get general solution, we take A is equal to 0, that is if sin theta is equal to 0, theta is equal to k pi, and when cos theta is equal to 0, theta is equal to 2k plus 1 pi by 2, and when tan theta is equal to 0, theta is equal to k pi for all k belongs to z. So this is all about the general solution, and these are the general solution for when this quantity is equal to 0, that is a is 0. So we can create also when a is equal to 1, we can also maintain its general value. These are the also zeros of the sin theta, cos theta and tan theta. So this is all about a general solution of trigonometric function. Now till now we find the general solution when a is equal to 0. Now we will solve the equation. For sin theta is equal to a, that is first case, and a lying between 1 and minus 1 and 1. So first we are considering the case sin theta is equal to a. Let sin theta is equal to a. It will be at particular value, say sin alpha. So suppose this is sin alpha. So we get sin theta minus sin alpha is equal to 0. So by using sum of difference in the form of product, we get 2 cos c plus d over 2 cos sin c minus d over 2. So we get either cos theta plus alpha over 2 is equal to 0 or sin theta minus alpha over 2 is equal to 0. As we know that if cos theta is equal to 0, we have theta plus alpha over 2 is equal to 2n plus 1 pi by 2 as discussed above. Or when sin theta is equal to 0, we get theta minus alpha over 2 is equal to n pi for all n belongs to z. Now from here we get theta plus alpha is equal to 2n plus 1 pi and theta minus alpha 2n pi for all n belongs to z. Also we get theta is equal to 2n plus 1 pi minus alpha, or theta is equal to 2n pi plus alpha for all n belongs to z. That means theta is equal to 2n plus 1 pi plus minus 1 raised to power 2n plus 1 alpha, or theta is equal to 2n pi plus alpha for all n belongs to z. That is for even and odd integers. If we see here, it is the positive always because there is an even integer minus 1 raised to power n. We can write here minus 1 raised to power 2n plus 1. So this condition holds for odd function. This is for even function. So by joining these two, we will get a general solution of the form just like replacing 2n plus 1 and 2n by integer k. K may be even or odd integer. So for any odd or even integer, that is k is equal to 2n plus 1 or 2n, that is sin theta is equal to sin alpha, if and only if theta is equal to k pi. K may be even or may be odd, and minus 1 raised to power k alpha. As k is odd number, it becomes minus alpha. As k is even number, it becomes positive alpha. So this is a general solution. Hence the solution set of Sin theta is equal to A, that is minus 1 less than A less than 1, is given by k pi plus minus 1 raised to power k into alpha, and k belongs to Z, where alpha belongs to minus pi by 2 to pi by 2, and sin theta is equal to A is equal to sin alpha. Now we will find out a general solution for cos. Now the next is general solution of cos theta is equal to A, where A is varying from minus 1 to 1. That is a range of cos function. Here minus 1 less than A less than equal to 1. Therefore, there exists alpha belongs to restricted domain 0 to pi such that cos theta is equal to A, which is equal to cos alpha. That is cos theta minus cos alpha is equal to 0. That is minus 2 times sine of theta plus alpha over 2, sine of theta minus alpha over 2 is equal to 0. That implies sine theta plus alpha over 2 is equal to 0, or sine theta minus alpha over 2 is equal to 0. So theta plus alpha over 2 is equal to 0. Sine is 0 when theta plus alpha over 2 is equal to k pi, and similarly here theta minus alpha over 2 is equal to k pi for all k belong to Z. So we get theta is equal to 2k pi minus alpha, or theta is equal to 2k pi plus alpha. On combining these two solutions, we can write that is, or theta is equal to 2k pi plus minus alpha for all k belong to Z. Therefore, general solution of cos function is given by theta is equal to 2k pi plus minus alpha for all k belong to Z, and cos x is equal to cos alpha, where alpha belongs to 0 to pi. Now it is a turn now to find the general solution of tan theta is equal to A, where A belongs to R, that is real number. Here A belongs to R, therefore there exists a unique alpha belongs to restricted domain, that is minus pi by 2 to pi by 2, such that A is equal to tan alpha, that is tan theta is equal to A is equal to tan alpha. That gives tan theta minus tan alpha is equal to 0. By changing tan into sin in the form of sin and cos, we get sin theta over sin cos theta minus sin alpha over cos alpha is equal to 0. So by taking the LCM, we get sin theta into cos alpha minus cos theta into sin alpha over cos theta into cos alpha is equal to 0. From here we get sin of theta minus alpha is equal to 0. This is sin A cos B, cos A sin B, then sin A minus B. So sin is 0 when theta minus alpha is equal to k pi for all k belong to Z, and cos theta and cos alpha is not equal to 0. that is theta is equal to k pi plus alpha for all k belong to z. Thus, for tan theta is equal to tan alpha, that implies theta is equal to k pi plus alpha for k belongs to z, hence the general solution. Set of tan theta is equal to a for a belong to R is given by k pi plus alpha for k belong to z, where alpha belong to minus pi by 2 to pi by 2. So this was all about when sin theta, cos theta, tan theta is equal to 0, where that is a is equal to 0, when a attains some particular value, that is 1, minus 1, half, 2/2, then there should be some angle, that is a solution of that equation. But if a is greater than 1, then there will be no solution in the case of cos theta and sin theta. So this was all about the general solution of trigonometric functions.